Okay, let's look at homework 8, problem number 6. Right, so we want to use this change of variable to evaluate this integral right here. Right, so let's do that. First, let's look at the region that we are integrating over. So in xy coordinate system, right, so here's x, and here's y. All right, so with respect to x goes from 0 to infinity, so from 0 to infinity, and y also goes from 0 to infinity. So we're talking about the first quadrant, so it's going to be the entire first quadrant. So just keeps on going, right? Right. So we're talking about first quadrant. All right, then we're gonna translate into UV plane. So let's draw that. So we have, let's see, I'm gonna draw a U axis. All right, and here's my V axis. Alright, so V. Alright, so let's think about, let's say, this positive x-axis right here. Right, so equation would be y equals 0. Alright, then of course, you know, x is greater than or equal to 0. Alright. So if you go through that, so y equals 0, so you're basically looking at u is equal to x squared, all right, and v equals 0, right? So this edge is actually transferred to, right, x is any positive, so you could be any positive value, and v is 0. So this guy is gonna be mapped to actually itself. It's the same thing, right? And how about the other edge? So if you look at you know, the positive y-axis right here, so that means that the x equals 0 and the y is greater than or equal to 0. Right? So if you plug those in, you see that the u is going to be equal to negative y squared, right? And the v is equal to, of course, 0, right? So v is 0 again, and but you can see that the u only takes a negative value. So it's going to actually map to the negative v axis, right? So we can see that the region is going to be, this is going to be the corresponding region right here. So instead of just the first quadrant, it's going to be a upper half plane, you know, above the x-axis. I mean, above the u-axis, I should say. Right. So I'm going to have to erase this a little bit. All right. So this is the corresponding region. Right. Then we have to find Jacobian. This is actually a little bit tricky because the Jacobian that we want, so J is actually, we have to take the partial of x and y with respect to the new variable, which is u and v. Right? But it's going to be very difficult because it's written as a u equals and a v equals. So what we can do is, this is equivalent to, right? This is easier to find. So partial of u and v with respect to partial with respect to x and y, right? This is just upside down, so I just have to take the reciprocal. So I'll just say, do that. All right, and so this is what you're looking for. Actually, we're looking for the absolute value of Jacobian. So absolute value of Jacobian, right? Do that. right? But this is going to be, let's see if you compute it, right? So take the partial, maybe I'll write it down. So partial of u with respect to x, and a partial of u with respect to y, and a partial of v with respect to x, and a partial of v with respect to y. Then we have to take the reciprocal of that, right? So this is gonna come out to be, I'm gonna go down here, right? Partial of u with respect to x would be just 2x, and the derivative of negative y squared would be 0 because we're taking the partial with respect to x. Right, partial of this guy with respect to y would be negative 2y. Right, partial of v with respect to x is 2y, and a partial of v with respect to y would be 2x. Right, we still need to take the reciprocal. Right, so the determinant would be 4x squared plus 4y squared, and with the reciprocal, so I'm going to just say 1 over that. All right, so if you do a change of variable here, we would have to do, let's see, so I'm going to call this guy integral I. Right, so that integral I can be rewritten as, so we have a double integral here. All right, then I'm going to leave x squared plus y squared as it is for now. Right, then you have 1 plus. Right, so you have x squared minus y squared. It's conveniently u, so it's going to be u, but you have a square here, so you have to, it's going to be u squared. Right, you have e to the negative 2xy, so it's going to be e to the negative, right, 2xy is v, so it's going to be e to the negative v. Right, and dx dy can be rewritten as Jacobian, which is 1 over, actually I'm going to factor out the 4 from the bottom, so that way we can write it as quantity x squared plus y squared. So this is going to be 4 and x squared plus y squared. Right, then you have a new variable which is going to be du over dv, not over, sorry, du dv. All right, then the region is, you can see that here u is all real numbers, so you're going to go from negative infinity to positive infinity. Right, then v is going to go from 0 to infinity. Right, then you can clean up a little bit, so you have let's see, x squared plus y squared on top, and the same thing on the bottom right here. Right, so we can clean it up as, right, there's 1/4 just a constant, so 1/4 kick that out of the integral. Then you have a double integral from 0 to infinity, and from negative infinity to positive infinity. Right, so you have e to the negative v over 1 plus u squared. Right, so 1 and the du dv. All right, then we can just evaluate it from here, so I'll let you guys do that. All right, that's it. I hope that this will get you going.